Unlock the future of pathology with Pathology News, your ultimate source for cutting-edge insights, expert analysis, and the latest breakthroughs in digital and computational pathology. Don't just stay informed, stay ahead.
Hello, welcome to our latest thought leader interview here at Pathology News. Now, today I have with me Prasanth Perugupalli, who is Chief Product Officer at Pramana. He has more than 2 decades of experience in design management, product definition, applications engineering, go-to-market planning, and product lifecycle management. Now, I will let Prasanth tell us much more about himself. Prasanth, hello, welcome to Pathology News.
Thank you, Jonathan. Nice to meet you here.
Great, nice to meet you too. And I think, shall we start? Maybe you could tell us something about yourself, particularly about perhaps your early career and how you came into this discipline of digital pathology, and obviously then the step into Pramana.
So I'm an electrical engineer by training, and I worked mostly in the wireless technologies in the earliest of my career, building power amplifiers and playing with essentially working on dealing with signals and systems. So over a period of time, as I delved more and more into product management and started to understand how overall systems are built rather than small parts and pieces of that, it gave me that ability to start thinking about what else would be interesting around in the space that I'm in. One thing led to the other, and there was an interesting opportunity to work with a research organization from Belgium called IMEC, who was looking to build a research team in India, looking on applying imaging techniques mostly to medical use cases. So I built a small team looking at how we could apply various kinds of imaging modalities. We dealt with hyperspectral imaging and a few other things of that nature. And I think it's serendipity. We were introduced to microscopy as one of the use cases by some of the pathologists, some of the physicians that we were working with in India at the time. This was back in mid 2010s. And the problem statement that was presented to us was that microscopy hasn't really changed much over several decades. And it was becoming evident that digital is on the verge of coming into microscopy. And there was a tremendous opportunity to actually build a system from ground up that looks at digital pathology more from a perspective of being an imaging modality rather than a microscopy or rather than a science modality. So here I am 8 years later, building systems that are, in my opinion, essentially high fidelity imaging systems that are needing to be smart enough to know what is the specimen, what is it that they're trying to look for, and morph themselves to be able to achieve the outcomes.
Okay, thank you. I'm thinking, I guess whenever we think about any commercial organization, the key factor is the customers and what they're looking for, the benefits they receive. So could you talk me through how some of those use cases that you talked about translate into the benefits for the customer institutions? I mean, what are they looking for when they partner with Pramana?
The idea behind our coming together was this aspect of saying, can we start from thinking about a software-defined hardware platform? I often try to call it as a hardware-software co-design. And can we do that in a fashion that essentially continuously works towards removing the decision-making or the need for the enigma, if you may, of the technology from the pathologist. Pathologists need to know what they need to know, just like what their brains used to give them when they were, looking under a microscope and looking for certain morphology to be able to make a call. And that's what even in the digital domain, they're supposed to be doing, maybe with some more enrichment, but they shouldn't have to worry about, why is it that a particular glass slide with a little bit different thickness behaves differently under a scanner? Or why is it that, the stain being just a little bit off produces a different color that eventually causes, things to go haywire, whether it is with an algorithm or the way that it looks on my screen, as an example. So what Pramana has been doing is to look at this element of how is it we can gradually cut away all the challenges that were posed to the labs as they wanted to go digital. So this has been our journey for the last 7 years. I believe we have done probably. I would be super happy to know that we have come maybe 70 to 80% along the way. I say 70 to 80% because I leave room for others in the industry to claim that they've come 50%. So we are a little bit ahead than the others, but I think we have still ways to go to be able to say, how do you take away all the pain points? Eventually, my view of how digital pathology needs to work is as simple as how imaging works today. When you make images with your iPhone, when you're visiting, a mountain resort, and you're not really actually worried so much about, am I adjusting some parameters? Did I get my image right? You click a picture, you walk away. You don't generally even take a look at it again until you get home and everything is good. You're not having that doubt and fear in your mind to say, should I be taking another picture right now? Because what if the previous one was not good? And that's what happened to photography. And that's because there's a lot of software that is laced around the hard. And in digital pathology, we are yet to achieve that. I think Pramana has been trying to push those barriers, faster than others. We have done very well in certain spaces, and we are continuing that journey at this point.
Okay, that's great. I think the iPhone's a nice analogy there, because rather as an iPhone is sort of almost built around the human hand, in that you can expand and open things up with your fingers. It sounds as though you're trying to build your solution rather like a sort of nice fitting suit for the pathologist almost. That's the impression I get.
So the ability for a device to be intelligent enough to handle most of those scenarios and do it in a fashion where it is essentially, adapting as it figures out what is it that I'm dealing with. It could start with knowing what is on the label and saying, I'm going to be most likely dealing with something that is an extremely faint slide. That automatically sets certain things in motion to say, I'm going to be doing certain things differently. Whereas it could be that I see multiple labels and there is information across those labels that is actually very valuable to concatenate that. You enter into a space where the way the slides are prepared, and the way they're handled by stainers, by cover slippers, different types of material, specimen types and such, they all bring a lot of variety to the problem. And that is a green field. It's a wonderful opportunity actually for an engineer in me to, and my team absolutely loves this part, that each time we see a new kind of a slide, it actually opens up possibilities to say, did we actually think through this from an autonomous perspective, or where is it we missed it? Where is it that the boundary condition was missed? And so as you gradually, if you think about it from a perspective to say, how can I make it extremely simple for the lab technicians, the lab managers to make slides, feed them into certain area and expect a guaranteed outcome, which is they don't have to worry about whether they got everything, from the physical slide into the digital domain. Was there something missed out, something not scanned properly, something not represented properly? Our goal has been to say, take away all that. Just like, again, going back to the iPhone analogy, the autonomous mode, or the auto mode on my phone, which I probably use 100% of the time. I don't go open any other things. That's what we need to achieve.
Well, let me ask you a specific question then. in that context, if I asked you to sum up for the audience your top 3 innovations, and I mean that within the context of how these make Pramana different, because this is a very competitive market, isn't it? There are lots of offerings out there, lots of players in the market. So
Yep.
tell me your top 3 innovations and how they make Pramana different and stand out in the market.
So let's see if we can keep it at 3, but I'll try. So the one of the first ones, which generally is not necessarily the top on a customer's list, but more from a perspective of a manufacturer, which has a lot of bearing as we go forward in expanding our reach and providing our technology to a lot more labs in the world, has been the aspect of looking at the scanner as a modular imaging device. And the idea of saying the imaging elements will have their own roadmap to be able to continuously improve and get more and more functionally efficient as well as functionally capable. And the whole aspect of handling of the slides and such and how they are fed to the scanners is a completely different piece of the instrument. And by having it that way, we've been able to essentially separately have two different roadmaps. And while we continuously improve the scanner from a perspective of hardware and software, and like I mentioned before about compute, we are able to very rapidly add capabilities from the perspective of handling various applications. So we are probably amongst the fastest in the industry to expand our portfolio to go from whatever we have learned in the anatomic pathology world to microbiology, to cytology, to handling wet samples and various other things by essentially separating these two. And having the scanner as a modular unit is allowing us then to achieve, manufacturing economies of scale, the ability to build the same units over and over again for various applications. And so that has been a pretty interesting, I would say, more than an innovation, it's a strategic advantage that we have been able to demonstrate to the industry to say you don't need to have these highly customized devices for each application. The second part of it was to do with our incessant, drive to say we wanted to essentially tell the labs all the time that you do not have to pay for quality coming from the scanner. You pay for a scanner, you pay for buying anything even at the supermarket, to buy a salad. You don't then pay for actually checking what is on the salad. Quality assurance is built into anything and everything, except in the case of how the market has actually developed for scanning and for whole slide imaging. So our incessant drive to say we wanted to ensure that we give a quality assured outcome to our customers, which basically meant that we had to build in quality assurance into our scanning process. We are aware when we are making the images, and we are aware when something is a little bit challenging. And the challenge could have been because, we hit a very thick region on a tissue or a cytology specimen, or we hit a bubble that formed underneath a cover slip. As long as we are aware of that, and we are able to correct for that, such that the end user, in this case, the pathologist, or maybe even a technician that is actually running these scanners, is capable of, it has been given that confidence that we would have done everything possible to get them the best images possible. To achieve that quality assured outcome is a true first from us, at least in the bright field imaging digital pathology space. And the reason why we were able to achieve that is because of a technology decision that we had made early on about what we would generally call volumetric imaging. So by essentially replicating a microscope in how a microscope is used by a user with course focus and fine focus adjustments and such. And even to the aspect of being able to say, I have to adjust things differently for a specimen versus the other, one specimen versus the other. We work towards replicating that in its true form using electronics and software. And so that has allowed us to be able to provide for quality assurance. So whenever there is an image, a whole slide image that is made from Pramana today, it actually comes with a focus stitching metric, a banding detector, and things like those that are already built into that image. So this has been a true innovation. And the third aspect of it, which is what is just starting to happen now, is the aspect of saying, how do you again go back and innovate on architecture, computer architecture, take advantage of a semiconductor roadmap that is continuously giving you more and more compute capability even at a desktop level. So everyone talks about GPUs, and GPUs are essentially, you look at the GPU roadmap, there is always a very high-end GPU. There's always a very big chunk of small, low-end desktop GPUs that have actually continued to grow in capability year over year. In fact, I would argue that that's a space that is actually getting bigger leaps year over year. When you go from the RTX, 3000 series to 4000 series to 5000 series, and the ability to utilize such a compute engine very, very close or inside the scanner, so that you're able to do real-time decisions on what is it you're trying to achieve, what is it that you're actually imaging, has been a revelation that we've been. I think we are probably, just right now touching the surface of that opportunity. But in a way, it is allowing us to start thinking in lines of how agentic AI is starting to develop. When I see something, when I see something in the environment, should I be doing something more? Should I actually apply a certain other parameter, if you may, from a scan perspective or from a illumination change perspective? You could argue there are a lot of different things you could do once you become aware of what you're doing. And so this is the third part that Pramana has done, at least been at the forefront, talking about it. And there is a tremendous interest coming from so many different, what I call them partners, who are very interested in saying, we can take very high advantage of that kind of a capability in your system.
You spoke a little bit about Pramana's future there and the way you're innovating, but I recently, I've bumped into two different labs who have young pathologists now coming through who have never signed off on a microscope. And that's really fascinating. And I wonder, you can comment on this in a moment, but I wonder how this world changes, this world of the clinical pathology lab over the next 10, 15, 20 years. Does the microscope take a back seat? Does it all go digital? Do we have two tiers of laboratories, some using microscopes, other using purely digital analysis? Could you comment on that? And, tell me how Pramana fits into that future as well.
The way I see this developing over a period of the next 3 to 4 years is that digital is going to be a requirement rather than a nice to have, because there are going to be more and more things that we will find out in the digital domain that otherwise would have been missed if someone was only looking at a glass slide under a microscope for a little bit of time. On the other hand, whether the aspect of, digital, and how is it that, algorithms would deliver towards a greater outcome. We believe that over the next several years, pathology is not just offering an outcome to the pathologists, but also talking to the oncologists or the physicians. And how is that possible? It's because it is moving beyond the element of only looking at the pathology diagnostics, but also quickly grabbing because of access to data, because of access to AI, quickly also making triangulations with other data sets and other elements, again, with the intent to, work at a little bit higher level and say, how could I organize the information from down below at a tissue at a sample level in a mode that is consumed by someone at a physician level, right? So we clearly see this to be a norm. The part that would be very interesting is how the models and the AI develops over a period of time. In my mind, I keep going back to this element of, looking at a digital thermometer versus, the mercury thermometer that I grew up in India using in my childhood. No one today even thinks of a mercury thermometer anymore. I don't know if in the US it's even allowed to even sell one anymore because of, environmental constraints. Um, we migrated to digital and, across the world. And, no one had any problem with paying for it because one, it was low cost enough. Two, it was seamless in its transition. Yes, there may have been some folks in a period of time that always wanted to go back to the mercury thermometer. But as the technology got so good that, it was almost, no brainer that you would just migrate, just that shift happened. And today, yes, indeed, there is a lot of technology behind that too, by the way. Some can be better than the others in terms of how they pick up the temperature and how they're converting it into a display and the displays themselves can be different. But the idea behind this has been to say, how is it done in a seamless fashion so that no one is actually having to sit back and think about it? So in an ideal world, one scenario that we see over a period of time is you have a case, and the case has been handed over to a vending machine of some nature, a kiosk of some nature, and the kiosk in the back end has all the necessary, imaging capabilities, compute capabilities, and such to be able to deliver an outcome, whatever that outcome could be. And sometimes that outcome is just images. Sometimes that outcome is, yes, indeed, I'm telling you ahead of time that this is a positive for a bacteria versus this is negative. Or it could be, even to say, I can tell you what the particular mutation that we think is the high probability is. These are all technologies that need to be running in the back end to provide that seamless user experience. So this is where clearly we see the opportunity for digital as we go forward.
Great, fantastic. Just one final question. I'm speaking to you from Europe. My colleagues are in Europe. So what are your plans for international expansion? Bringing your technology out to the side of the pond.
So we are taking a guarded approach, Jonathan. We started with the US because that's where we are located, and that's where our very first foray into the market happened. We are rapidly growing first in the US. This is a very large market and largely untapped for us, for that matter, for all of digital pathology. In Europe, we've been working with certain partners, distributors in several locations across, right now in the Western European area between, France and Germany and Italy and such, and expanding into UK. We just received our CE approval from the devices about a year ago. And since then, we have been starting to look at what is the go-to-market strategy. How do you expand? A big chunk of it, again, calling a spade a spade. These are some of the challenges that a relatively new startup has in terms of making decisions on how do you grow, such that you're able to provide the same seamless user experience. And so it starts with being able to, teach or demonstrate to the lab professionals or the lab technicians how their life gets better with our systems, and learning from pathologists, and also being able to give back to them on areas that matter most, with European way of doing things being different from in the US, as an example. So we are taking we are growing. This year, we would see a lot of our presence in Europe. We have deployed our systems at a couple of locations already in Germany, in Austria, and soon in a few other locations as well across Europe. So there is European expansion in plans for this year. So you will see us show up at every conference, and you'll see a lot more of us. I would say on the other side of the Atlantic. And then we are also evaluating our strategy in terms of how do we grow beyond that into Asia, into South America. A lot of it will come from partnerships. A lot of it will come in a distribution mode to start with, as we start to understand where is the technology proliferating, and then we gradually plan to bring in more reinforcements into that area. One of the challenges that we see in general is the aspect of the adoption rates themselves. We are seeing a lot more uptake in surprisingly in microbiology and cytology, which are areas where we are actually seeing a lot clearer outcome. In microbiology, there is a yes/no answer that someone is looking for. And so when you have an algorithm and a decent image management system wrapped around those images, now you produce an outcome for the user. And that is starting to break down the barriers. People are not looking at, is my anatomic pathology department digital? And because I don't want to be the first torchbearer. So there's a lot of inbound interest coming in from various places in Europe, in North America, for the work that we do in partnership with TechSite, one of our partners that we have announced, where we build a very cohesive solution together that actually takes images, runs algorithms, and then talks back to the images at the right time to say, am I getting everything right? So that we are essentially demonstrating that first wave of what I said about seamless imaging and seamless outcomes.
Uh-huh.
And so we are seeing European expansion happening on that front pretty rapidly. You'll hear a lot about that in the US as well. So we do plan to, I think 2025 will be a big expansion year for us in those lines. So you'll see us a lot.
Fantastic. So the future's bright for digital pathology, and the future's bright for Pramana. And very important information for our listeners there, that you are expanding into other territories as well. Prasanth, that's all we've got time for today. It's been a real pleasure talking to you, and it's wonderful to hear about Pramana and learn some new information about the company. To our listeners, thank you for being with us, and we'll see you on the next Thought Leaders piece. Prasanth, thank you very much. Thanks for your time.
Thanks so much, John.